Section 1.7, Inductive Reasoning. Inductive reasoning is making conclusions on patterns you observe and on past experiences you have had. A conjecture is the conclusion you reach based on inductive reasonings, based on your experiences and your observations. Let's look at an example. Use inductive reasoning to make a conjecture based on your observation. What will the next figure look like? Draw the figure. Here I'm given 3 circles. The first one is shaded. Then it goes to the next one and the next one. So it looks like the shading is going clockwise. Therefore, it should repeat the pattern. And if that is the case, my next figure should look like this. In other words, it repeats the pattern. Here, I can do number sequences. So let's take a look at another example. Use inductive reasoning to make a conjecture based on your observation. What will the next 2 numbers be? Here, I start with 15, I go to 12, 9, and 6. So it looks like this is subtracting three on the last digit. So if that's the case, 15 minus 3 is 12, 12 minus 3 is 9, 9 minus 3 is 6, 6 minus 3 is 3, and finally 3 minus 3 is 0. Here I want to describe the next figure in the pattern, then draw the figure. It looks as if I have a circle, a square, a triangle, a rectangle, and then it repeats. So it looks like I have 4 figures and it repeats the pattern. If that's the case, I go from a circle to a square. So I have 4 patterns, or 4 figures, and it repeats. And if that's the case, it goes back from a circle to a square. Not a rectangle, but a square. Here, I want to write a rule for each pattern, then find the next 2 numbers in each pattern. Here I'm given 1, and then a half, and then a fourth, and then an eighth. What it looks like is going on is I'm multiplying each previous number by a half. One half times 1 is a half. 1 half times 1 half equals 1/4 times 1 half is 1/8. And if that's the case, 1 half times an eighth, 1 times 1 is 1 over 8 times 2 is 16, 1/16. And then multiply that by a half. 1 times 1 is 1, and 16 times 2 is 32. Here we have counterexample. A counterexample is an example that proves a conjecture false. So if somebody comes up with a conjecture and you know it's false, you need to come up with one counterexample. That's all you need, is one counterexample to disprove that conjecture or make it false. Is each conjecture correct or incorrect? If it's incorrect, I need to give a counterexample. First example, you can connect 3 points to form a triangle. So any 3 points forms a triangle. No matter what you do, these 3 points will form a triangle. At this point, if I move these points anywhere, it looks like I can always connect them with 3 segments that will form a triangle. Therefore, at first observation, it does look like this is correct. But if we look at it a little differently, what if I draw a line, which obviously is not a triangle? And if I put these 3 points on the line, now I've moved these 3 points on the line. And obviously, they don't form a triangle. Therefore, my counterexample is, if these 3 points lie on the same line, they can't form a triangle. Therefore, this is false. You can connect any 3 points to form a triangle. False. These 3 points are connected, and they don't form a triangle. One counterexample, and the statement is false. Next, is each conjecture correct or incorrect? If it's incorrect, give another counterexample. Number 2, any number and its absolute value are opposites. Well, if I write a -2, any number, I selected -2, and its absolute value are opposites. Well, let's take the absolute value. Absolute value of a -2 is 2. Well, obviously, a -2 and 2 are opposites, so that proves that this is correct. But if I select 2 itself, let's just start with 2. The absolute value of 2 is 2. These are not opposites, so this does not work. I could even test again. Let's go 12. Here's a number that I selected, which that's asked me to do. Here's my given number, and I want its absolute value. The absolute value of 12 is 12. Notice that also are not opposites. These are not opposites, these are not opposites. So here are actually 2 counterexamples that make this statement false. Again, the same directions. Prime numbers are numbers that only have factors of the number 1 and itself. And actually, this is the definition of a prime number. So therefore, this is true.